Hey guys, welcome to day 27 of 100 Days of Code. Today we're going to be diving into graphical user interfaces using Tkinter, and we're also going to be learning more about function arguments. So we've already seen a little bit of graphical user interfaces when we use our Turtle module, but I want to go a little bit more in depth. And I want to show you one of the most popular ways of creating a graphical user interface. For example, a program like this in a separate window. And we're going to be using the inbuilt Tkinter module to do this. So we're going to learn how to create labels, how to create buttons, how to respond to those button clicks, as well as things like text inputs and how to lay out and design your programs. And while we're doing all of this, we're going to be looking at more advanced features of Python functions, including things such as how to set default arguments and what these args and quargs are. So a way of being able to pass an undefined amount of inputs into a function. And we'll apply these advanced concepts to build a unit converter program using Tkinter. This program is going to help us convert miles to kilometers or liters to gallons or whatever little conversion that you might often use. For example, let's say that I ran 10 miles and I want to know how many kilometers that is. If I go ahead and click calculate, you can see it generates the equivalent value in kilometers, and you can see that our whole program is nicely laid out. So it says 10 miles is equal to 16 kilometers, and it's fully responsive to our inputs. This is what we're going to be making as our project, a fully fledged Python graphical user interface program that uses our Python code. So once you're ready, head over to the next lesson and let's get started by learning a bit more about Tkinter. All right, so our main goal in today's lessons is to learn about the Tkinter module and see how we can use it to create graphical user interfaces, also known as a GUI or a GUI. Now, GUIs were a huge deal back in the 90s because previously, in order to interact with a computer, you had to use a command line operating system such as MS-DOS. So this is kind of similar to our Python console, where everything we wanted the computer to do, we had to tell it by writing a piece of text. So if we wanted Python to print hello, we had to write out the text. But GUIs were different. GUIs are graphical, and accompanied with a mouse, they allowed a user with very little training in computers to be able to just point and click on the thing that they want to do on the screen. And one of the earliest computers that incorporated this type of GUI operating system was the Mac Lisa. It had these little windows which you can click on, and it launches programs which you can interact with by pointing and clicking. Now, I mentioned that the Mac had these windows, and in fact, the Mac had program windows before Windows actually existed. So Windows was Microsoft's version of the graphical user interface operating system. And when it first came out, it created quite a bit of controversy because it seemed like it might have stolen this idea from Apple. Because after all, the Mac Lisa came out way before even Windows 1, let alone Windows 95 or the later versions that you might be familiar with. And this even led Apple to sue Microsoft for infringing on their intellectual rights for using this graphical user interface to interact with the computer. This is how big a deal GUIs were back in the 90s. They were such a big breakthrough in interacting with computers, and that made it so important to both Apple and Microsoft that they ended up battling in court. Now, even to this day, Bill Gates gets asked whether if he actually copied the graphical user interface idea of an operating system from Steve Jobs and Apple. And I read on a recent Reddit AMA where somebody asked him this question. He actually responded by saying that the copying wasn't really copying. It was just that they hired some people from another company, Xerox PARC, and it just happened that they were continuing on the work that they were working on before. But the more colorful piece of history actually comes from the biography of Steve Jobs by Walter Isaacson. And in there is this brilliant depiction of this scene where Steve Jobs, surrounded by his employees, is basically just going off on Bill Gates, telling him that you're ripping us off, I trusted you, and now you're stealing from us. You saw the earlier versions of our operating system, and you're now using it in your Microsoft software. And to his credit, Bill Gates actually managed to come up with a pretty good response on the spot, where he said, well, Steve, I think there's more than one way of looking at it. I think it's more like we both have this rich neighbor named Xerox, and I broke into his house to steal the TV set and found out that you had already stolen it. That was a pretty good comeback from Bill Gates. And the Xerox that they're referring to is Xerox PARC. It's the Palo Alto Research Center that was creating loads of breakthroughs in terms of the computing industry. And in fact, they created the first graphical user interface that was actually put into use in a computer before Apple or Microsoft even thought about it. They also created other things like the Ethernet or the first object-oriented programming language. And most importantly, they also created the first graphical user interface that allowed a user to interact with the computer by pointing and clicking. And they even developed the first mouse to allow people to do this. So this is a little bit of Silicon Valley history that is particularly fascinating. If you're interested, there is a movie called Pirates of Silicon Valley that goes into this story in more detail, and this is where I first found out about it. But coming back to what we're doing, I just wanted to show you just how important the graphical user interface was when it first came about. So we're going to learn how to use Tkinter to create our very own graphical interface programs so that we're no longer reliant on these console-based or text-based programs, and we're also not working within the playpen of the Turtle module. We're going to be building some big boy and big girl programs now. So let's get started. Let's get started by, as usual, importing the relevant library. Tkinter, like the Turtle module, is already pre-installed with every installation of Python. As long as you've got Python running, then you should be able to simply import Tkinter as the module, and then you'll be able to use all of the classes and properties and methods inside. So, for example, we could start off by creating a new window. And this is sort of equivalent to the screens that we've been working with in Turtle. So in order to do this, we have to dig into the Tkinter module and then find a class called TK. And then once we initialize a new object from that class, then we have ourselves a window. But if I run this as it is, you'll see absolutely nothing happen. And it will just go straight away to exit code 0. And the reason for this is because we need a way of keeping the window on the screen. What Tkinter has done here is it's gone ahead, created the window, sees that there's no more instructions, and then it basically ended the program. Now what we want instead is to sort of have a while loop that basically just keeps on running. So something like a while true. And inside this while loop, it holds on to this window and keeps on listening to see if there's anything else that the user is going to do to interact with that window so that it can respond when that happens. So this loop is included inside Tkinter, and all you have to do is get your window to simply call the main loop. This main loop is the thing that will keep the window on screen like this. So now here is our window, and here's the line of code that keeps it on the screen and listens for what the user will do to interact with it. For example, click on a button or type something. Now, this line of code always has to be at the very end of your program, and all the rest of the things that you're going to write go in between creating the window and getting the window to run. The next thing we can do is we can change the title of that program, and we've done this before using Turtle. We just call the title method and we give a string as the input. So my first GUI program, And now if I rerun my code, then you can see that this is what's showing up at the very top bar of my program. Now, other things that we might want to change with the window is the sizing of it. So there is a default size, and there's also a way of changing the size. And we can do that by tapping into a method called minimum size. The window is going to scale to include all of the components that you put inside. If you put 100 buttons inside, it's going to make the window massive. But if you don't have a lot of things in the window, then you might want to define a minimum size so that you can specify that by default, I want my width to be, let's say, 500, and the height to be 300, unless the user wants to resize the window or there's a lot of components that makes the window a lot bigger. So when we run our code now, you can see this is a 500 pixel by 300 pixel window that we've just created with our own custom title. In addition to creating windows, we can of course create some components to put inside the window. So I want to show you firstly how you would create a label. Just as our window was created from the Tkinter module and it's the TK class that was used, there's also a class inside Tkinter called a label. So we can initialize a label class and we can save that to a variable called myLabel, or anything else for that matter. Now, this label has quite a few things that we can change about it. It might not be obvious from the documentation or from the prompt that PyCharm gives us, but we can in fact change a property called text, so we can change what is displayed inside the label. Let's just write some text called I am a label. Unfortunately, that's actually not enough to get the label to display. So when I run my program as it is, you don't actually see a label anywhere on the screen. When we're working with Tkinter, what we have to do is we first have to create a component like a label, and then we have to specify how that component is going to be laid out on the screen before it will show up. And one of the easiest ways of laying out any component is just to get hold of that component and then call the method called pack. And this is going to place it into the screen and it's going to automatically center it on the screen. So now if I run the code with this modification, you can see our label is now finally showing up and it's packed so that it's in the center of the program. Now, there's other properties that we can modify about our label. So we could initialize our label with a piece of text, but we can also specify a font. The font is again going to be a tuple, and that tuple is first going to take the name of the font. So let's say I want to use Arial, and then it's going to take the size of the font. So let's make it a little bit bigger, maybe a 24 size font. And finally, it's going to take whether if it's bold or italic, or let's just set it to bold. And now if I run my code again, you can see I've now got a Arial font, size 24, and it's bold. You can also change this to italic, or you can simply just ignore it and leave out that last item, and it'll just give you a regular piece of text. But none of this would show up unless you had this line of code where you actually use the packer to pack our label onto the screen. Now, in the course resources, I've linked to the Tkinter documentation on the Python docs, and they talk about the packer in a lot more detail. It's basically a geometry management system. It's just a simple way to lay out the components that you're building. And this packer has a number of options. So if we scroll down, you can see that we can change the expand to a Boolean, so true or false, and that tells it whether if it should expand to take up the entire space or stay as small as it can be. Alternatively, you have things like side, which changes which side should it be packed to on the left, right, top, or bottom. So we know that currently our label is bang in the middle, but if I change the side to equal left, now when I run the code, you can see it's now been packed to the left of the screen. And if I say bottom, then it's going to go to the bottom and right and top. All of those will work. And if I change expand to true, you can see it's now trying to take up the entire height and width of the available screen size. Now, when you're writing this pack function here, as soon as I type pack and I open up my parentheses, normally we're used to a whole bunch of properties being listed in here for us, and we can specify each one and pick and choose basically. But in this case, this is all that we see. So what's going on here? Compare this to when we used our turtle module, and I'm going to build a turtle, Tim, turtle.turtle, and then I say tim.write. Look at how when I open up the parentheses here, you can see there's the argument, which is the object that's going to be written, and then whether if the writing should be moved to the bottom corner, which direction it should be aligned, what's the font, and all of the available inputs that we can give to this write function. Now compare that to our pack function here. This, you'll notice, is really different. Now, if you actually look in the documentation for pack, you can see it actually has a number of things that we can change: before, expand, fill, in, side, and all of these things which are modifiable and do various things. But how is it that it doesn't seem to exist as one of the arguments that we can use? The secret lies in this last part here, the asterisk KW. And in the next lesson, we're going to talk about some more advanced features of Python arguments. And we're going to look at how we can provide default argument values, how we can define unlimited positional arguments, and unlimited keyword arguments. To understand this better, head over to the next lesson and we'll do a deep dive on Python arguments. In the last lesson, we saw how different it was when we tried to use the turtle's write function. We saw all of the arguments available listed versus when we tried to use the Tkinter labels pack method. And notice how there's actually very few arguments that are listed. And yet somehow there's all of these parameters that we can change when we look at the documentation, like expand or side. So let's set that side to equal left, and I'm going to delete the rest of the turtle code. And now you can see our label is placed on the left side of our screen. How is it that these parameters, even though they're not listed in the list of properties, how is it that we're able to use them just by typing them in? Well, to understand this, we have to learn a bit more about advanced arguments. Not how to argue better, but how to use advanced Python arguments in order to specify a wider range of inputs. We've already seen how keyword arguments work. For example, here I have a function and I have 3 keyword arguments, A, B, and C. And when I call the function, I can provide those inputs A, B, and C in any order I want, as long as I've got the keyword in front. So C equals 3, A equals 1, and B equals 2. Now, what if when I use this function, it's 9 out of 10 times A is going to be equal to 1, B is 2, and C is 3? Why is it that when I call the function, I always have to put in these values? That seems a bit of a wasted effort, right? Python has a very neat way of solving this by creating arguments that have default values. We can do this by simply changing the function declaration. So when we create our function, we can already give it some values to start off with. So we can say that A should be equal to 1, B 2, and C 3, and these are the default values. So that means when I call this function and I want to use the default values, I don't actually have to provide any inputs, and it will just go along as it would before. Now, if, however, I wanted to modify one of those inputs, let's say I wanted to give a custom value for B, rather than let it be equal to the default value of 2, well then I can just change the value of B. B equals 5. And the rest, so A and C, will still take on their default values. Notice when I call tim.write, this write method takes 5 inputs. self because it's a method and associated with the turtle class. It takes an argument, which is what it is going to write, move, align, and font. Now, if I wanted to use tim.turtle to just write some sort of text, I can actually just put in this. And when I run this code, you'll see that I've got some piece of text being written. But how is it that I've got all of these other inputs, which I've just basically completely ignored? What about move? What about align? What about font? Well, as you can see, they have the equal sign ... which is trying to tell you that they've already got a default value. And in fact, if I hover over this write function, you can see that in the quick docs that pops up, it tells me that the arguments are the arg, which is what it is to be written to the screen, move, which is optional, which can be set as true or false, align, which is optional, font, which is optional. The reason why they're optional is because all of these actually have a default value. For example, move by default is false, align by default is centered, and there's also a default font. So that means that all we have to do is just to provide the required arguments. If I don't add anything at all when I call this write method, you can see I do in fact get an error here. And it says write is missing one required positional argument, which is that first arg, which is the thing that it's expecting to write. I mean, if you're calling Turtle to do some writing and you're not telling it what to write, that's a bit of a problem. So this arg is a required argument because it doesn't have that equals ... at the end. So this you have to provide. But once you've done that, then the rest of them all have default values. They already know how to behave and what to do, even if you don't tell them anything extra. Now, however, if you wanted to modify one of those arguments, let's say I decide to change the font to something completely different, like Times New Roman, and make the font super large, 80 size font, and change it to bold, then you can see that that optional setting gets implemented, and it's now changed the font, and it's changed the size, and also made it bold. But this was completely optional. And this is all down to creating the function with default values. In the last lesson, we looked at how to provide default values for optional arguments. In this lesson, we'll discuss how to create functions that can take any number of arguments. Let's say that we had a function called add, which adds n1 and n2, and it just returns the sum of those numbers. That's very well and good, but what if I wanted to add more than two numbers? Well, I would have to add n1, n2, n3, n4, but then I would have to add 4 numbers every single time. So what if I wanted to make this function more flexible and to allow any number of arguments to be used as the input? Well, what I can do is to simply change the code to use this asterisk and then the name of my parameter. That name, args, is by convention what most Python developers will use, and it simply stands for arguments. But you don't have to stick with that naming if you don't want to. But what you do need is that asterisk. That's the really important part. What that tells Python is this function add can accept any number of arguments. And once inside the function, you can actually loop through all of the arguments, which is going to be in the form of a tuple, and you can do whatever it is you want with each of those arguments. Instead of now passing in only 2 arguments, because that was fixed when we created the function, we can now pass in any number of values, like 4 values or 7 values, and we can do whatever it is we want with them. Let's try this code out. I'm going to delete the code related to Python Turtle, and I'm going to create a new file called playground.py. And we're going to use this playground.py to test out what we've just learned. I want you to have a think about what you just saw in the slides and see if you can create a function called add, where you can pass in as many numbers as you want, and it will always add together all of the numbers that are being passed into the function as the input and then return the total sum. Pause the video and see if you can give that a go. Alright, so what we want to do is to be able to call this method add, for example, down here, and pass in any number of values, right? Let's just go with 3 to begin with. And then we want to receive all of those values inside this function and then add them all together. So we're going to use that asterisk trick. So one asterisk, and then we can give a name to the arguments that we receive, which normally is just called args. Now that we've got these args, if I actually go ahead and print it out, and we go to run and then run and change this to our playground, you can see it's basically just printing out a tuple. And that tuple represents all the inputs that were passed in when this function was called. And in fact, if I do a type check on this args, you can see it is indeed a tuple. Now, once we've got hold of this args tuple, we can actually loop through it. So we can say for n in args, for each of the numbers in that tuple, let's go ahead and print each of them. You can see it's now separated them all out, 3, 5, and 6. So that makes it easy enough for us to create the sum. So let's create a sum which is equal to 0, and then instead of printing out each of the n, we can just add the n to sum, and finally outside the loop we'll return our sum. So now when we print this final result by calling add 3, 5, 6, you can see it's now added 3, 5, and 6. And we can call this method in different ways. We can add more values to it, 2 and 1, and you can see it's now equal to 17. And you can basically keep going because it can take any number of values. This is all done by this asterisk keyword, and it basically packs all of these numbers that you've put in as the input into a tuple called whatever it is you want it to be called. So you could call it numbers if you want, or you can stick to the default, which is just args. And then once we've got that args inside the function, we loop through it and we can do whatever we want to each of the values. Now, in addition to looping through it, you can also access them by index, because it's a tuple after all. So we can say args at position 0 like this. And if I print that out, you'll see that the value is 3 because the first one is 3. So that's why these unlimited arguments using this asterisk args is also known as unlimited positional arguments, because the position of your arguments which you pass into the function matters a huge deal. Because if I fetch the one at position 1, it will no longer be 3 and it'll now be 5. So this is a way for us to be able to define a function and specify a unlimited or unspecified number of inputs. In other words, the number of arguments for the function can vary because the asterisk operator collects all of the arguments into a tuple. However, what if we wanted to refer to our arguments by name rather than by position? Well, that is exactly what we'll talk about in the next lesson. So I'll see you there. In the last lesson, we saw how the asterisk operator could be used to provide any number of positional arguments to a function because it collected them into a tuple. In this lesson, we'll take a look at the double asterisk operator, and this is going to allow us to work with an arbitrary number of keyword arguments. Let's see this in action. So let's say I create another function called calculate, and this time I'm going to add 2 asterisks, and in this case I'm going to call my argument quargs, or keyword arguments. What we've done now is we've added 2 asterisk signs in front of this parameter name, and we've now created unlimited keyword arguments. What this allows me to do is I could basically now call this calculate function. I could pass in a keyword argument, for example add, and let's give it a value, maybe 3, and then let's add another keyword argument which I'll call multiply, set that to equal 5. And effectively, what this has been turned into is these quarks, which is basically a dictionary. So if I print these quarks, you can see what gets printed is basically a bog standard dictionary. And in fact, if we do that type check thing again, so type, you can see it is in fact a dictionary. This dictionary basically represents each of the keyword arguments and their values. So add is now a key and 3 is now its value, multiply is the second key, and 5 is its value. What I can do here is I could do the standard way of looping through dictionary. So I could say for key, comma, value in quarks dot items. And then I can get access to each of the keys and the values as I loop through the dictionary. Like this. So add 3 multiplied by 5. Alternatively, I can simply use the names of the keys. So I could just simply print my quarks and then use the square brackets and then provide the name of the key. So add, for example, and that will give me the value, which is 3, as you can see here. Now, what this allows me to do is it basically lets me look through all of the inputs and find the ones that I want and use them to do something. So, for example, in this case, it's a calculate function, right? So we could, let's say, start off with a normal positional argument. So let's call it n. And let's pass in that n at the very beginning. So let's say we start out with the number 2. N is now equal to 2, and then the quarks is a dictionary of the remainder arguments. Let's say that I wanted to do some calculations. I wanted to say n plus equal the quarks, and I'm going to get hold of the value under add. And then I'm going to say n multiply equal the quarks, and I'm going to get hold of value of multiply. So now when I go ahead and print my n, you can see that what happens is it takes the first value 2 as equal to n, and then n, this 2, is going to be added to the number I wanted to add, which is 3. So 2 plus 3 is 5. And then it multiplied that 5 by whatever it is I had stored in multiply. So 5 plus 5, and we get 25. This gives us a more flexible way of working with these arguments, and it gives us a way to name the values that we're passing in to this function. Now, coming back to what they've done in the Tkinter module, basically this Tkinter module is actually ported from another technology called TK. And TK actually has a very different syntax from Python. In order for it to work, they basically took all of the TK commands, like creating a label or packing some sort of item, and took all of the options and turned them into these quarks, or optional keyword arguments. And that is why when we create a new label from the Tkinter module, or when we call the pack method, you can see that it doesn't actually come up with any properties that we can modify, other than this asterisk asterisk kw, which is the same as our quarks. So we could actually create a class like that as well, because this is done at initialization, right? This is done when they're creating that label class. Let's say that we create a class like this, which I'll call car, and in the init, what I'll include in addition to self is star star kw or quarks, or however you want to spell it. This kw are going to be all of the optional arguments that I'll pass in when I'm initializing a new object from this class. I can say, for example, self dot make of the car equals kw, and then from kw I'm going to get the make, and then I'm going to have self.model, which is going to be equal to kw and then model. And of course, all of the spelling matters, so make sure you don't make any typos. And then I decide to create my car, which is going to be the object created from this class. Now, notice how when I open up the parentheses here, you don't actually see any of the properties like make and model show up when I'm initializing. All you see is asterisk asterisk KW, just in the same way as you see it here. Asterisk asterisk KW. And that, of course, refers to our optional keyword arguments. Let's add some values. Let's set the make to a Nissan, and let's set the model to let's set it to a GTR. And now I can use my object just as I would any other object. I can say mycar.model, and when I hit run, you can see I've got GTR being printed here. And if I decided to print make, you can see it gets hold of the make. Now, what if I didn't actually specify one of these arguments? Notice how it's now actually going to crash. It tells me that key error model. So when it was initializing this car object, it fell on this line and it couldn't get hold of a value called model from this KW argument dictionary. In fact, with dictionaries, we can get hold of the values through the square bracket method, but we can also use a function called get. And we use get in a very similar way to the way we use the square bracket. We just pass in the name of the key, and we want to get hold of the value. But the benefit of get is that if this key doesn't exist in the dictionary, then it will just return none and it won't give us an error. So now if I run this code again, you can see that everything works, but my car.model is now equal to none. So this is how we can actually create a class with lots of optional keyword arguments. So we could have a self.color or self.seats. And depending on what it is we want to initialize this car object to, then we can simply go ahead and add whatever it is we want to set as the make and the model, or the color and the seats. And in the same way that we're using this label class, we can set the text, or we can set the font, we can set all of the options, or we can leave them as the default values. That should help you understand how this code works a little bit better. And the reason why it works like this is, as I say, mostly because this module was converted from another language, and this just happened to be the most efficient way for them to do this. Now, with other more Pythonic modules or things that have been created in Python, like the turtle module, then you'll see more bog standard kind of code like what we've been working with. So when we initialize a new turtle, you can see that it has a default shape, it has a visible Boolean, and we can set all of those properties that we can see in this prompt. Now, in the next lesson, I want to dive deeper into the Tkinter documentation, and I want to show you how we can create other components, not just a label, but things like buttons and text inputs and a whole range of things that will bring our GUI program to life. So for all of that and more, I'll see you on the next lesson. In the last lesson, we saw how we could set a lot of the properties for the methods associated with Tkinter, or for initializing the components like our labels. Now, in the documentation, they tell us that there's a number of ways that we can set these options. We can either do it when we initialize a new object, or we can access the properties like as if they are keys in a dictionary and then setting the value. And finally, we can set multiple properties by using the config method and passing in the value for each of the things that we want to change. I recommend taking a look at the TCL/TK documentation, which lists all of the options. Like, for example, here I've got my label chosen, and there are standard options like background color or text. And there are widget-specific options, so specific to the label, you can change its height, you can change its width. Coming back to my label in my main.py, if I wanted to change my labels property, so for example, if I wanted to change the text that's inside, and I want to make it different from the initial text that it displays, then I can do simply this by changing it as if it were a dictionary, and I can set that to the new value, so new text. Now I could also do it by doing mylabel.config and then passing in the text as a keyword argument. Either way, when I run this main.py, remember previously we were running our playground, so go back to run and then click this and then change it to our main.py. And now you should see the new text show up instead of the original text, which is I am a label. So this is how we configure and change or update the properties of a particular component that we've created. In addition to labels, we can also create buttons. Let's create a button, which again is going to come from the Tkinter module, and it's going to be the button class from that module, as you can see right here. Now, all of the components that we're going to be using come from this class. Very often, you'll see people, instead of importing Tkinter, they'll say from Tkinter import, and then the asterisk to denote import every single class. This means that we can basically get rid of all the module mentions, and we can just initialize our window as TK, our label as label, and our button as simply button, like this. Saves a little bit of typing, depends on how many of the classes you're going to use. If you're just going to use one, I recommend keeping the module so that you know where it comes from. But if you're going to use loads of them, like we are here, then it does make it a lot quicker to type. So let's create our button, and again, it has a whole bunch of optional keyword arguments. And some of those are standard. So for example, we can change the button text in the same way that we change the label text. So let's make this say, click me. And remember that in order to make anything appear on screen, it needs to have some sort of layout. So let's call pack again to get it to be packed onto the screen. So now if I run this code as it is, you can see that my button has been placed in the middle of the screen and my label is packed to the left. Let's go ahead and get rid of that left so that it actually goes in order, so that the first thing gets created, gets put on screen first, and then the next thing is the button, and then this is all centered by default. The next obvious question is, how can we get this button to actually work? Because at the moment, clicking on it does absolutely nothing. As you remember, when we used our turtle module, we could have an event listener. So we can create some sort of a function. Let's call it, say, button clicked. And then this function could do something. Say, for example, I got clicked. And when this button detects an event, say a click event, then it could call this function. So in the Tkinter world, there is a property called command, which you can set to equal the name of a function. So remember, it's the name of the function, not calling the function. So we don't actually need the parentheses at the end. Now, when we run our code, when this button detects a command, which is basically a click event, then it's going to trigger this method and it's going to print this hopefully into the console. So let's hit run, and now I'm going to click on this button and you can see it says I got clicked, and it does that every time I click on it. So here's a challenge for you. How can you make the label, my label, instead of reading new text, for it to say button got clicked when I click this button? So this button click should now change the text. Pause the video, give that a go. All right, so we know that we can change our label's text by using either of these methods. So you can basically pick one of these and add it to this function. So I'm going to use the mylabel.config just because it kind of makes a little bit more sense when I read that line of code. So I'm going to configure the text property to read button got clicked. And now when I hit run, what you'll see is when I click this button, it's going to change the text. So we're now getting a little bit more interactivity. The next thing I want to show you is even more interactivity. I want to show you a component called the entry component. And this is basically just an input, effectively. So let's create a new object, which I'll call input. And it's created from the entry class, which comes from our Tkinter module. Now, again, if we want something to appear on screen, we have to give it a layout, and we can use the automatic pack to do that. So now when I run this code, you can see I've now got a input field. Now, if I want to look at the options for my entry, I can simply go to this TK documentation, find my entry, click on it, and you can see I've got standard options and widget specific options. Now, one of the things I want to change is the width. For example, I could change the width of this input by simply using the width keyword argument, and I can specify an integer to indicate the desired width of the entry window. So at the moment, if I think it's a little bit too wide, then let's try modifying our input so that it has a slightly lower width. Let's change it to maybe 10. And you can see it's now a lot smaller than before. Now, what if I want to get hold of the value that came from that entry? Well, in that case, I have to use the get, which basically just returns the entry's string. So I could say input.get, and then this method is going to return the input as a string. So I could, for example, print it out. But unfortunately, the point when this line of code is run, there's actually no input inside this entry. So we would actually print absolutely nothing. Here's a challenge for you. Can you figure out how to get whatever is written in here to be the text in the label the moment when I click on this button? Given that I've typed something in here, when I click this button, I want that something to be displayed in the label instead of button got clicked. Pause the video and see if you can complete this challenge. All right, so we know that the trigger for the button is the button clicked function. So it's here where we're actually configuring our label. If instead we're going to get hold of our input here and call input.get to get the new text, well then we can actually use this new text and populate the label. So we can say text equals new text. And now when I hit run, you can see that I can type whatever it is I want in here. And then when I click me, it gets the text inside the entry and puts it in the label. This is how we would work with some of the most basic components of Tkinter, like label, button, entry, and we've also seen the pack method. Now, as you can see, there are other things that you can do with Tkinter. So in the next lesson, we're going to be working on top of what we've done so far, and I want to show you some of the other widgets that you can work with and add to your Tkinter program. Now, in the last lesson, we saw a couple of different ways of working with Tkinter widgets. We've already seen how we can create labels, so something like this, and also buttons that can be clicked and do some sort of action. Then we've also seen entries, which is basically some sort of text box. And now I want to show you some of the other widgets that you can work with. For example, the text entry box, which allows you to use multiple lines of text, or something like the spin box, which is basically a sort of counter, which lets you go up and down. And then a scale, which is a slider basically that you can move along its axis and change its value. Then there's a checkbox, which can be on or off, basically just a tick box, radio buttons, and finally a list box of choices which you can pick from. So these are pretty much all the widgets that you can work with. To save you from typing a lot of this example code, I've created a Tkinter widget demo replit for you, which you can go to, and you can see some of the existing code that we've already created, like how to create a window or how to create a label and how to create a button. But I want to show you some of the other features by just looking at the code. For example, with the entry, we can actually insert some text for the entries to start off with. So notice how here we can click on it to edit it, but it's already got some starting text in there. So for example, if you wanted to create an email box, maybe you would write the word email to give the user a bit of a hint. Now you've also got a text box, which is a large area where the user can edit. And this is simply created with the text widget. You can set the number of lines as height and the width as the width of the box. And you can set the text to be focused so that the cursor starts out in that text box. And then we can insert some piece of text to begin with. And we can also get hold of the text inside the text box using the get method. Now, notice there's something a little bit weird, like the end here and the end here. This is just an index to allow Tkinter to figure out which particular item you're referring to. And you don't have to change it ever. This is just the code that you use. You can keep the code exactly as it is here and just modify the text that you want to insert. And this 1.0 basically refers to getting hold of the text starting from the first line at the character 0. And then we've got a new widget that we've never really seen before, a spin box, which looks something like this. So you can click on the up and down to change its value. And we can print out the value that's being changed in there by simply getting the spin box to be tied to a function, which is called spinboxUsed, and then we just get the value each time. Now, a scale is also pretty self-explanatory. You can move it up and down, and we're getting hold of the value that the user is landing on by simply packing, again, another command into that scale when we're creating it. And then when that function is called, it actually passes over the value that the scale is currently on, and that is what's getting printed. Next, we've got a checkbox, and we can click it on or off, and we can print 1 or 0 by simply tying that checkbox to a variable. And this variable is something that's defined by the Tkinter module as a int var. So this is actually a class. And once we create that object from the class, then we can add it to our check button when we create it, and that variable will keep track of the value of that checkbox, 1 for on and 0 for off. And then we can print it out when that check button is used. Now, radio buttons are useful to pick between different options. So normally you'd have a number of options and only one of them can be selected at any one time. So in this case, what we do is, again, we create a int var and we tie that var to each of the radio buttons that we create. And then we give each of the radio buttons a value. So this one has value 1, this one has value 2, and they're both tied to that radio state int var. And then when that button gets changed, then we can actually get hold of the radio state by calling radiostate.get, and we get whichever value it is that's currently selected. So option 1 or option 2. Now, finally, we've got a list box, which is just a list of options created from a Python list. We loop through each of the items, insert it to our list box, and then once the list box is used, we use this bind function to call this particular callback. This way, whenever we select any of the items in here, it will print out and get the current selection. Now, a lot of this code is pretty much going to be used the same each time, so it doesn't really matter if you don't understand fully exactly what some of these weird components are. It's just a factor of how this Tkinter library has taken this TK module and turned it into a Python format for us to be able to interact with it using Python. So there's a few weird bits like this list box select or this end being used here, but you can see that each line is commented and it tells you what it does. So you'll be able to figure out what line of code you need to write in order to add some text or to get some text, or how to bind a function to the list box, and how to get hold of the value that's currently being selected. I recommend heading over to this link here and either downloading the code and opening it in PyCharm if you prefer, because then you can actually get a much larger version of the running program, or alternatively just have a play around with the code in here so that you understand how these widgets work and how you can use it basically as a palette if you wanted a couple of checkboxes, or if you wanted a couple of spin boxes, then you can just pick and choose them from this cookbook essentially, and then you can put them into your programs when and as needed. Now, coming back to our main.py, our previous program had a label, a button, and an entry, and it was relatively simple. So I'm going to head back to this main.py file where we've got only 3 widgets so that I can show you how we can define the layout and positioning of each of our widgets. Firstly, I've reconfigured the file a little bit, so I've moved the button clicked function to the top, and I've made sure that each of the pack methods are at the very end of each widget. That way we'll be able to work with it quite easily. Now, as I mentioned before, Tkinter has a whole bunch of different layout managers that define how to position each of the widgets in your GUI program. Now, there's 3 that you should know about: pack, place, and grid. Now, firstly, we've already seen pack, and all that pack does is it basically packs each of the widgets next to each other in a vaguely logical format. And by default, pack will always start from the top and then pack every other widget just below the previous one. As I mentioned, you can change this by adding a side parameter, and you can change it to, for example, side left. And if you change this for all of the packs, then it's going to pack everything starting from the left edge of the program, like this. And you can change that to bottom or right as well. But the problem with pack is that it's actually quite difficult to specify a precise position. So for example, if you wanted this label to be a little bit up and then this button a little bit down and this entry all the way to the right, it's very, very complicated to do that using pack. And that's why there's not just a single layout manager, but there's lots of others. So let's take a look at the next one, which is called place. Place is all about precise positioning. So when you place something, you can provide a X and Y value. So for example, I can say my label.place, and then I can say, well, the X value should equal 0 and the Y value should equal 0. And this just places that label at the top left corner. Now, it's important to remember that if a widget gets created, but it doesn't have any layout specified using pack, place, or grid, then it won't be shown. As you can see here, we've only got the label showing up. Now that we've placed our label to the top left corner, we can try placing it somewhere else. So let's move it a little bit along the x-axis. So let's say place it at 100, 0. That moves it to the right a bit more. And if we want to move it down, we can change the Y position. So now it's down at the bottom, and then the X is 100. Now remember, we've defined the width and height. So the width is 500 pixels, the height is 300 pixels, and anywhere along that screen, you can define a X and Y value for a particular widget to place it at that precise position. The downside of place on the other hand, is the fact that it is so specific, and we have to work out in our head the coordinate and where to put each widget. It's simple enough if you've only got 3 widgets like we have here, but if you have 100 or 50, then that becomes quickly a bit of a nightmare to manage the precise coordinates of each widget. So in addition to pack and place, there's also a final layout manager, which also happens to be my favorite one, which is the grid. And the grid is a really simple concept. It imagines that your entire program is a grid, and you can divide it into any number of columns and rows that you want to. So just as a reminder, the rows are the ones that go along the horizontal, and the columns are the ones that go along the vertical. If I remove my place and instead I use my grid, I could say my label.grid, and then I can provide a column and a row number. So let's say I'm going to put it at the first column and the first row. So then it starts from 0. So we could say column equals 0, row equals 0, and you can see that it gets placed in the top left corner. Now, the grid system is relative to other components. So even if I change this column to, 5 and the row to 5, you can see that it doesn't actually change the layout because there is no widget in column 4, 3, 2, or 1. So it's still the first one in the grid. So the easiest way of working with the grid is starting with the thing that you want to be at the top left, defining a starting column and row 0, 0, and then for the next and subsequent widgets to just keep going through it and define its position on the grid. For example, if I wanted the button to be on column 1 and row 1, and then I want my entry, which is called input, to be on the grid in column 2 and row 2. Now, if you run this, you can see it's now been laid out along our grid. And this is effectively what it looks like. Our label is in column 0, row 0, button in column 1, row 1, and entry in column 2, row 2. This is one of the easiest ways of visualizing and creating the layout for your Tkinter programs. And it's really flexible and it's really easy to imagine and understand. So this is always my preferred way of working with the layouts for Tkinter. Just a word of warning though, you can't mix up grid and pack in the same program. So for example, if I wanted my label and my button to be defined by the grid, but then I decide to use the pack method for my final entry, then you can see I actually get an error when I run my code. It says cannot use Geometry Manager pack, which already has slaves managed by grid. So these two are incompatible with each other. You basically have to choose one or the other. And often I will choose grid because it's just more flexible and more easy to understand. So now here comes a challenge for you. I want you to change the code that we've already written so that we end up with this layout. So we've already got a label, a button, and an entry. I want you to add a new button, and it should be positioned like this. Have a think about how you might solve this challenge using the grid system that you learned about just now. Pause the video and complete the challenge. All right, so the first thing you notice is that the label is still at column 0, row 0, button is still at row 1, column 1, but this new button is now at row 0, column 2. So let's go ahead and create it. Now I'm just going to create a new button and I'm not going to worry about its command or any of that. I'll give it a piece of text just so that we can identify it, and I'll call it new button. But then the most important thing is how we lay out this new button. So I'm going to use the grid system and I'm going to give it a column of 2 because it is 0, 1, 2, the third column from the left, and then row is going to be 0. Now, when I run this code though, you'll notice something a little bit odd. Why is the entry below the button? Because in our example, the entry is actually over on the right of this new button in a new column. By putting this new button in between the old button and the entry, we've actually changed the positioning of that entry on the grid. So we've actually had to move it along into the next column. So to do that, we have to change the grid of our entry. Instead of having column 2, to make it column 3, just so that it's on the right of this new button. And now when I run it, this has the exact layout that we wanted, and we've now learned a little bit about how we can precisely position our widgets in our program using the Pack, Place, and Grid layout managers. The very last thing I want to show you with relation to layout and design of our GUI programs is how to add a little bit of padding around components. The easiest way to add padding is actually to directly modify the widgets. So for example, if I wanted a bit of padding around all of the elements in my window, so basically add it around the edge of the window, then I could simply say window.config, and I can change the padding in the x-axis and the padding in the y-axis, so pad x and pad y. So now if I run this program as it is, you can see that there's now more space being added around all 4 edges of our program. Now I can make this a lot more extreme. So let's say I add the pad X to be 100 and the pad Y to be 200. You can see just how much padding we've now added. And this just means that you add more space around your program and it makes things easier to see and looks a little bit nicer. If you want to add padding around a specific widget, not just the entire window, then you can do the same with that widget. So we could get hold of my label and again using config to change the pad X and the pad Y. So let's add maybe, 50 pixels of padding in the X and in the Y. Now you can see that around that label, there's a whole lot of space so that it pushes everything else away and actually makes the entire program window a lot bigger. So this is just a way for you to be able to add space around your widgets so that they're not all crushed together, and it helps you with your layout and your design. All right, guys, it's finally time to put everything you've learned so far today into practice and build our miles to kilometer converter. This is what the end outcome will look like. This is our GUI program where we've got a text entry, we've got some labels, and we've got a button. So I should be able to type in some certain number of miles, and then when I hit calculate, it should give me the equivalent number of kilometers. Now, here I've rounded it to the nearest whole number, but feel free to decide however many decimal places you want. But the important thing is for it to work, firstly, but also for you to be able to use and put in all of these components and to follow this layout. Just to break the layout down, you can see I've got a entry widget, and then these are all label widgets, and finally I've got a button widget. And they're divided along a grid that looks more or less like this. Have a think about how you might create the layout and the design first, and then go ahead and add the implementation and see if you can complete this project. So pause the video now and give it a go. Feel free to either create it inside your main.py by commenting everything else out, or as in my case, I'm actually just going to create a new file, which I'll call the mile to kilo converter.py. Inside this new file is where I'm going to create my project. And first of all, I'm going to go ahead and import everything from the Tkinter module. So import asterisk, and now I've got all of my classes. The next thing I'm going to do is to, of course, create our window. So that's going to be created from the TK class, and my window is going to have a title, which I will call it miles to kilometer converter. And finally, we're going to get our window to be displayed and started off in the main loop. Right now, if I run this file, miles to kilo converter, you can see I've just got a blank window with the title miles to kilometer converter. Afterwards, the next thing to do is to create all of our widgets and lay it out on screen. If we look at this breakdown, you can see we've got one entry widget here and then 4 different label widgets at each of these positions. And then finally, I've got a calculate button down here. So I'm going to create each of these widgets and then I'm going to lay them out on screen. Firstly, I've got a miles input widget, which is going to be created from the entry class. And then I've got a label, which is the miles label. And that's going to be created from a label class. And the label is going to contain some text. The text is just going to say miles with a capital M, like this. Now, the next one we're going to create is our is equal to label. So I'll just call it is equal label. And this one is going to have, again, just some text. It's not really going to have much functionality. And then we've got our label, which is actually going to be the kilometer value. So I'm going to create that as the kilometer result label. And that's going to start off just with a big fat 0. And then finally, I've got the kilometer label. And this is just going to say km. And the final thing that I need to create is that calculate button. And then we will be done with our widgets. And this is just going to have the text of calculate. So now I've got all my widgets created. If I go and try to run this code as it is, you'll see none of them get displayed because none of them have been laid out on the screen. At this point, it's also good to mention that if you accidentally left out one of these keyword argument names, then you will actually get an error. And the error will read something like this. String object has no attribute tk, which seems a little bit confusing, but basically, if you see that, then just have a look, make sure that you've actually got that text equals in there rather than just the actual string. That's a really common mistake that students make. So the next thing I want to do is to use my grid layout method to lay out all of these components in the correct positions. So I'm basically going to have a grid with 3 columns and 3 rows. So this will be column 0, 1, 2, and then this will be row 0, 1, 2. So that should be relatively simple. And let's start with our miles input dot grid. And we're going to write a column number and a row number. Now I'm just going to copy this because I'm going to need to use it quite a few times. And then I'm going to refer to the end result. And you can see our entry is here. So it's going to be on column 1, row 0. And then let's define the miles label on the grid. And this one I think is going to be column 2, row 0. And then I'm just going to go through all of these widgets and define them on the grid. So there you have it. We've got all of the columns and rows that correspond to the positions of each of these widgets in our final layout. Now, if I run my code as it is, you should see this version show up. Now we've got to do some refinements. And the first thing you notice is that this entry is way too large. So let's go ahead and change its width. And I'm going to change it to just 5 or 7, basically not very wide. That way it'll be a lot smaller like this. And then we're going to use the method that we learned previously to give our window a little bit of padding by changing its config to add a pad X and a pad Y. And you can pad it however much you like, but In my case, I think 20 pixels should make it a little bit larger and a little bit easier to see. So now that we're pretty much done with the layout, let's go ahead and actually add the functionality. We're going to need some sort of function which converts miles to kilometers. The miles is going to be inputted in the miles input. We can get the miles by calling miles input dot get, and then we can convert that into km by using some sort of formula. If we search in Google for miles to km, you can see that the formula is pretty much multiplying the mile value by 1.609. That's simple enough. We'll say miles multiplied by 1.609, and we get the value in kilometers. Then we have to set our kilometer result label to show this updated result. So we're going to get hold of the kilometer result label, and I'm going to call config on it to change its text property to this new value, which is going to be our value in kilometers. Now we have to be careful with the data types here, because when we get hold of the input from that miles input, this is still going to be a string, but we want to multiply it by a number, so we have to change it to an actual number. Because people could type decimal place numbers, I'm going to change it to a floating point number, like this. Now I've got a floating point number multiplied by a floating point number, so that's perfectly valid. Now next, when I actually want to put that number into a label, I need it as a string. Instead of simply just adding this kilometer in, I'm actually going to use an F string so that I wrap this kilometer variable inside my F string, and then I convert it into a string to put into this label. Now all we have to do is to trigger this function miles to kilometer when the user presses the calculate button. And if you remember, the way we do that is by tying it as a command. So command equals miles to kilometers, but without the final parentheses, because we only want it to be called when it actually gets clicked. Let's check our code and see if it actually works. Let's check what 20 miles is in kilometers. So if I click calculate, you can see it gets calculated, and that label there, that kilometer result label, gets changed. If you want to leave it as this, that's perfectly fine. If you want to, you can also round this up so that it becomes a whole number, and you end up with something that looks a little bit more slick, but maybe a little bit more imprecise. That's how you complete this project. Now, of course, the world really is your oyster. You've learned about way more widgets than we've used here, so you could incorporate anything else that you've seen, like maybe add a radio button or a checkbox, and you can modify this to maybe not just do miles to kilos, and you can try playing around with the code and creating your own version of the program. If you create something fun, be sure to share it with us in the Q&A below the lesson so that we can all admire and congratulate you on your hard work. So I hope you've had fun building your first GUI programs using Tkinter. In tomorrow's lessons, we're going to be diving deeper into Tkinter, and we're going to be looking at how to create some more complex but more interesting programs as well. So for all of that and more, I'll see you there.